In the previous video, we've seen that when you differentiate this, you would get this. So what that means is that when you're asked to integrate this, you can say the integral of this is inverse sine of x plus a constant. But then suppose you have a coefficient in front here, in front of the x here, then it becomes a lot more complicated. So let's now investigate what happens when you have a constant in front of this in front of the x. So now let's say you've got this here. Hang on. So now let's say you've got a constant here in front of the x here. So so this is like us saying inverse sine of let's say 3/7 x here. Look what happens when you try and differentiate this. So so using our normal routine, sine equally to both sides, that will then give you this. Now from here, use implicit differentiation. So this is our normal routine. Differentiate this, it will give you cos of y, but because y is a function of x, you need to use a chain rule here. And then when you differentiate this, it will give you a over b. Okay, so now now dy by dx equals this thing here. So dy by dx equals this thing here, but we don't want the answer in terms of y. So now we need to go back to here, and then yeah, we will need to go back to here, and looking at this, we need to use this to translate the cos of y, because here we've got dy by dx equals this, but we don't want the answer in terms of y. So we would need to go back to here, use this to translate this. Okay, so looking at this here, you would need to create a scenario in such a way that it would represent this thing here. So let's say the angle here is sine. The angle here is y. Sine of y would be this. So create a scenario in such a way that this thing here is satisfied. So so let's say this length here is ax over b, and let's say this length here is, let's say, 1, a convenient 1. So now well, using Pythagoras, this length here will be the square root of 1 minus this whole thing here squared. So yeah, so it would be this thing here. Okay, so this thing here is this length here. So now we can say cos of y is really this thing divided by 1. So so that would then give us this. Okay, and so that would then give us this. And by the way, you could, instead of setting up this scenario, instead of setting up this scenario, you could set it up like this. Hang on, you could set it up like this. So so this here is y, the angle here is y. Sine of y would be this, and looking at this, you could set it up as this: ax, and then set this length to be b. But then it wouldn't tidy itself up neatly. You see, if you set it up as this, as opposed to this, then this is 1, and then later on you're going to have something divided by 1. It's a bit hard for me to just try and explain this by rushing through it. But if you try to set up like this, it doesn't really tidy itself neatly. You want this to be a 1 here, so it tidies itself up. Well, anyway, you could set it up like this if you want to, but this here would be a lot easier. So anyway, translating this, it will then give you this. It will give you this. So what that means is that when you differentiate, hang on, let's go back here. What it means is that when you have a complicated coefficient in front of the x, this, if you differentiate this, it will become this. It will become this. So so your coefficient here lands in front of what we're used to here. So hang on, what that means is that if you try and differentiate this, it will give you this whole thing here. So now if you're asked, let's say for example, you're asked to integrate this. Let's say you're asked to integrate this here. Looking at this here, this looking at this here, everything's of exact same form as this. So look at this, 1, 1, divided by square root, and then you've got a 1 here. The point that I'm trying to make is that this is in a very similar form as this. So what that means is if you try and integrate this here, now looking at this here, this is exactly the same as this. So if you try and integrate this, you could make this to be your initial guess. You could make this to be your initial guess here. Inverse sine of 3 over 7x. So you could make this to be your initial guess. But when you differentiate this, it will give you 3 over 7 times 1 over root 1 minus a. But hang on, it will make sense later. It will give you this. But you see, you don't want this thing here, so you need to negate this thing here. And the way you negate it is by making the adjustment to your initial guess. Making the adjustment to your initial guess would be making this as 7 over 3. So when you integrate this here, it will be 7 over 3 inverse sine of 3 over 7x. Okay, so when you integrate this, it will give you this. Okay.